Welcome to the channel. Today we are going to talk about one of the most disruptive technologies in Industry 4.0, digital twins. These enable the creation of accurate virtual replicas of physical products, processes, and systems, helping companies to simulate scenarios, anticipate problems, and optimize performance. We will see how they are transforming business management in sectors such as manufacturing, healthcare, and logistics. If you want to know how they work and what their key applications are, stay until the end of the video. A digital twin is a virtual replica of a physical object, process, or system that collects real-time data from sensors and other sources of information. We can see how real-time data is combined with simulation models to reflect the current state of the physical system. This allows companies to monitor and analyze the performance of their assets without the need for direct intervention. For example, in manufacturing, a digital twin of a machine allows its behavior under different operating conditions to be simulated, helping to predict failures and plan maintenance. The operation of a digital twin is based on data integration and simulation. The key components of a digital twin are shown: physical model, the digital representation of the object or process; real-time data, information collected through sensors, including variables such as temperature, pressure, and velocity; modeling and simulation, software tools to analyze the behavior of the digital twin and simulate changes. A practical example is General Electric, which uses digital twins to manage its wind turbines, adjusting parameters in real time to maximize efficiency. Digital twins have multiple applications in manufacturing. We see how Siemens uses this technology to simulate and optimize its production lines before physical changes are made, adjusting machine design and reorganizing workflow. In addition, they are used to implement predictive maintenance, anticipating when failures are likely to occur and allowing companies to plan repairs before serious problems arise. Rolls-Royce, for example, uses digital twins to monitor its aircraft engines and reduce maintenance costs. In logistics, digital twins make it possible to simulate different transportation and warehousing scenarios. It shows how DHL has developed digital twins of its distribution centers to optimize the layout of products in the warehouse and improve the speed of operations. This has enabled the company to reduce handling costs and improve efficiency in the delivery of goods by adjusting routes and delivery times based on real-time demand. In healthcare, digital twins are revolutionizing personalized medicine. It shows how Philips has developed digital patient twins to simulate the response to different treatments. This allows doctors to choose the best therapeutic option before performing an intervention, improving outcomes and reducing risks. This technology is particularly useful in the treatment of heart disease, where doctors can predict the patient's response to different procedures. Digital twins represent a fundamental change in the way companies manage and optimize their operations. They offer a holistic view of the physical system, enabling organizations to anticipate problems, reduce costs, and improve decision-making. As this technology continues to evolve, it is expected to be further integrated with artificial intelligence and the Internet of Things (IoT), becoming an indispensable tool to stay ahead of the industry. If you want to implement digital twins in your company to improve efficiency and decision-making, contact me on LinkedIn for a personalized consultancy. Together, we can develop an advanced simulation strategy that maximizes your resources and optimizes your operations. And don't forget to subscribe to the channel for more content and learn how to buy time for your day-to-day business.